All right, let's take a look at this balloon and badger problem. But first, what I want to do is show how we got to this point. So, the concept and skill we're studying here is what I call start and change problems. And they come up all the time in all different kinds of contexts. So, we start off solving problems like this. We have this person, and he has so much money saved up. He's trying to buy this game quad that cost that much money, and he's saving at that rate. So we have the three things that we need to set up one of these start and change problems. We have a starting value of $38. We want to get to an ending value of $384, and we're changing at a rate of $41 per week. So we can set up an equation that looks like this. We take our change times some variable that kind of matches the problem. In this case, we're measuring in weeks, so we'll use W, plus our starting value needs to equal our ending value. So for this particular context, our change is 41, plus our starting value of 38 needs to equal our ending value of 384. Now, previously in class, we've studied how to solve equations like this. So we can solve our equation and come up with our answer. So in this case, we end up with W being equal to 8.439. And from the context of the problem, we can see that after 8.439 weeks, he's got enough money, but he only saves once a week, so we're going to have to go to that next week to have enough money, plus a little left over, so he's going to have enough money in 9 weeks. Once we get done with problems like that, we move up a level, where we have problems where we try to match two things together. So in this example, we have Fred here, and he has $260 saved up, and he's going to save at a rate of $12 per week. And then we got his buddy Elmer here, who has $145 saved up, less money than Fred, but he's saving at a rate of $19 per week, which is greater than Fred. So eventually Elmer catches up with Fred. So we can set up an equation now that's sort of the same thing. We have one start and change value is equal to the other person's start and change value. So in this context, one person's start and change is the end of the other person's and vice versa. So we can now set up an equation for this situation. We have Fred here as 12. We're measuring again in weeks, plus his starting value of 260 needs to equal Elmer's $19 change plus his starting value of 145. Once again, we've studied how to solve equations like this as a previous skill. So we can solve this equation, get our answer. And we end up with our value of W being equal to 16.428. And again, with the context of the problem, we're going to have to go on to that next 17th week to have one have more than the other. So our solution, 17 weeks. All right, so now we're ready to go back to our original problem. So here was our context, and we need to read through the problem and figure out what's going on. So we have the balloon here that is on the ground, and that leads to a starting value of 0. Okay, the balloon is ascending at a rate, it rises at a rate of 17 feet per minute, while the airplane drops the wooden badger from an altitude of 4,500 feet, and it is falling at a rate of 127 feet per minute. So we can translate these now into an algebraic equation that we can solve. So for our balloon, once again we're measuring in minutes. So our balloon has a rate of 17 feet per minute plus a starting value of 0, which needs to now equal the airplane, which is at 4,500 feet, but the wooden badger is falling at a rate of 127, which leads to a negative change. It's falling, going down. So negative 127 m plus its starting value of 4,500. Once again, that now gives us an equation that we can solve. Right, so when we work out our solution, we come up with m being equal to exactly 31.25. And that's in minutes, so the 0.25 we can convert now to seconds. 0.25, or 1/4 of a minute, is 15 seconds, so our time until the balloon and wooden badger collide is 31 minutes and 15 seconds. Right, so the whole idea behind these problems is to be able to think algebraically, to take the situation and convert it into an equation, the equation we can now solve.